Pleasant morning to my dear lovable students. Welcome to Max class. In this conversation, we are going to discuss about exercise 6.1. Moving to question number 1. So, question prove by vector method that if a line is drawn from a center of circle. So, one circle is there. The point center. So, origin means to the midpoint of a chord. So this is one of the chord. This is midpoint of this chord of the line, both the side A and B. Then the line is perpendicular to the chord. We have to prove perpendicular of the line. Okay. Example, if you join means definitely we will get it to right angle triangle, isn't it? This is center of O means this is considered for C. So the proof of the line, midpoint of the chord, then the line is perpendicular. Line is perpendicular means the chord of the line AB is there. So we have to prove OC vector is perpendicular to AB. Already you know what is the meaning. For example, A vector perpendicular to B vector means A vector dot B vector is equal to 0 means we can say A vector perpendicular to B vector. I will prove. Let C be the midpoint of chord AB, first line. Now second line, O be the center, isn't it? So let O be the center. So midpoint of the chord AB means consider for radius both the side, consider for RR. Okay. Then let modulus of OA vector is equal to modulus of OB vector is equal to R. Both the side radius is there. So that's why I can write radial. That is plural form. Radius. So both the side R is there. That's why I written for radial. Okay. Then again let consider for OA vector is equal to A vector. Then OB vector is equal to B vector. Now what we have to prove? Prove perpendicular drawn. Prove perpendicular to drawn OC vector dot AB vector. So now first we need to find out actually AB vector. So first, before moving to the AB vector, then first we have to identify. Prove by perpendicular to OC means what will happen? So AB means AB vector is equal to first OC vector we need. Yeah, the OC vector. Look at there. How to find it actually? OC vector means what is the meaning? OA vector plus OB vector divided by 2, isn't it? So OC vector is equal to OA vector plus OB vector divided by 2. Therefore, OC vector is equal to OA vector consider for A vector. So, A vector plus B vector by 2. This is OC vector. Next condition, perpendicular means AB also we need. So, the condition perpendicular drawn. Perpendicular drawn means if you consider OC vector perpendicular to AB means OC vector perpendicular means what is the meaning? OC vector dot AB vector. OC vector dot AB vector is equal to, so OC vector as it is, OC vector dot, then what is the meaning of position vector for AB? OB vector minus OA vector. OB vector minus OA vector. Now look at there, already we found OC vector is equal to A vector plus B vector by 2. So A vector plus B vector by 2 dot, OB vector means B vector minus A vector. Now we can interchange, because both the set plus is there, so we can write it is equal to B vector plus A vector dot, this is B vector minus A vector. Now whole term divided by 2 is equal to, numerator look at the A plus B into A minus B form, therefore we can write it B vector square minus a vector square divided by 2. If you take square means we can write it without vector also. B square minus a square we can write it, because next step we need b vector means already we know the b term. What is the meaning? OB vector. Therefore we can write it OB vector square minus OA vector square. B vector square means we can write it OB vector square minus OA vector square divided by 2. Already we know OB vector means both the side R, isn't it? Therefore we can write it R square minus R square divided by 2. Now R square plus R square minus R square cancel means 0 divided by 2. So 0 divided by anything means we have answer 0. Therefore we can say OC vector dot AB vector is equal to 0 means we can say OC vector perpendicular to AB vector. Therefore we can write it hence. Okay, I will continue the next question. Question number 2. Prove by vector method that the median to the base of an isosceles triangle is perpendicular to the base. So exercise 6.1 first question. The center of the circle we have to prove perpendicular to the base of the circle. But here given median to the base of an isosceles. Isosceles means the two sides are equal, isn't it? So consider for one triangle. This is consider for O means then A, B. Then midpoint we have to take it, what is the name? C. Okay. Now proof. The perpendicular base means definitely OC perpendicular to AB. So perpendicular to AB means we have to prove OC vector dot AB vector is equal to 0. So look at, let C is the midpoint of AB. Let C be the midpoint of AB. First condition, midpoint of AB. Then each and every side condition. Then let OA vector consider for A vector. Then OB vector consider for B vector means the condition, what is the meaning? OC vector dot AB vector. If you have the value 0 means OC vector perpendicular to AB. So first we need to find out OC vector. OC vector means definitely we can say OA vector plus OB vector divided by 2, isn't it? So OC vector is equal to OA vector plus OB vector divided by 2. OA vector consider for A vector, no? Therefore we can write it A vector plus B vector by 2. That is OC vector, isn't it? Now prove median of OC vector perpendicular to AB, isn't it? Perpendicular to AB. Therefore we can write it OC vector dot AB vector is equal to OC vector as it is dot position vector of AB means OB vector minus OA vector. Before moving to this point, already we know isosceles triangle means definitely OA vector modulus is equal to, then modulus of OB vector is equal to, two sides will be equal. So consider for value both angle we have the value x, okay, because isosceles, no. Now look at there, OC vector dot OB vector means B vector minus A vector. What is the meaning of OC vector? OC vector means A vector plus B vector by 2. So A vector plus B vector by 2 dot B vector minus A vector. Just you have to interchange B vector plus A vector dot B vector minus A vector whole term divided by 2. Again we have to apply A plus B into A minus B. What is the formula? A square minus B square. Therefore B vector square minus A vector square divided by 2. What is the meaning of B vector? OB vector square minus OA vector square divided by 2. Already we know modulus of OB vector and modulus of square means we can write it without square, we can write it. And therefore OB square minus OA square is equal to divided by 2 means already we know isosceles already considered for modulus of OB as well as modulus of OA considered for X means we can write it X square minus X square divided by 2. So plus X square minus X square cancel means 0 divided by 2. So 0 divided by anything means what the answer we have? 0, isn't it? Therefore Therefore, 0 divided by 2 means 0. This is actually what is the value? OC vector dot AB vector. So, OC vector dot AB vector is equal to 0 means we can say OC vector is perpendicular to AB vector. Therefore, we can write it hence proved. Okay. I will continue the next question. Question number 3. Prove by vector method that an angle in a semicircle, okay, is a right angle. Semicircle, no? Draw one semicircle means this is A and B. Center of the point O means whatever the place here or where the places in semicircle I will consider for here means this is considered for point of P, okay. Now look at there. So proof of the line. Let AB be the diameter of the circle. A be the diameter of circle with the center O. Okay, with the center O, no? The first condition. Then the second one, P is the origin point with O, isn't it? Second condition, P be the any point on the semicircle, isn't it? P be the any point on the semicircle. Now let OA is equal to modulus of OB as well as modulus of OP is equal to R, isn't it? R means both radial. So radius actually each and every time consider for R is there. That is why I have written for plural of radius. Okay. Now the condition also over. Now what we have to prove actually? PA perpendicular to PB. So PA vector is perpendicular to PB means what is the meaning? PA vector dot PB vector is equal to 0 means we can say in a semicircle is a right angle. So first we have to prove the 0 value, isn't it? Now first we have to find out the PA value. Okay. Now the another one condition, angle of to prove angle of APB is equal to 90 degree or pi by 2. Okay. That is one of the condition. Now we are moving to find out PA. So PA means definitely PO plus OA. PO vector plus OA. Now next one PB. PB means PO plus OB. PO plus OB. Now look at there. Starting with O, no, but this is midpoint, each and every side term will be equal, but same side the opposite direction, isn't it? So instead of OB we can take it OA means minus. Therefore PB vector is equal to PO vector minus OA vector because opposite direction now from center of O minus OA vector. Now PA vector plus PB vector is equal to PA vector plus PB vector is equal to what is the value of PA? PO vector plus OA vector plus again PO vector minus OA vector, isn't it? Now look at there. again A plus B, dot of the form. Sorry, this is dot, no. PA vector dot PB, isn't it? So PA vector dot PB means dot means what will happen? Again A plus B into A minus B form. So A square minus B square means PO vector square minus OA vector square. So square means we can write it without vector also. So PO square minus OA square. Now already we know that both this term will be radius, each and every term will be R. Therefore we can write it R square minus R square is equal to 0 means what will happen? PA vector dot PB vector dot PB vector is equal to 0 means we can write it PA vector is perpendicular to PB vector. Therefore we can write it hence. Okay, I will continue the next question. Question number 4. Prove by vector method that the diagonals of a rhombus bisect each other at right angles. So I will consider for rhombus. So rhombus A, B, C, D. So two diagonals. We have to prove actually AC is perpendicular to BD. We have to prove according to the question. The proof, let A, B, C, D be a rhombus. Then conditional, AC and BD are true diagonals. Then AC and BD are true diagonals. Okay. Now the condition, modulus of AB is equal to modulus of BC is equal to modulus of CD is equal to modulus of DA. Consider for all the length will be equal now. Consider for one letter A. Okay. Now what we have to prove? To prove AC perpendicular to BD. Okay. This is we have to prove. Question number 4, isn't it? So after getting to prove AC perpendicular to BD, isn't it? So AC perpendicular to BD means what is the meaning? AC vector dot BD vector we have to prove equal to 0, isn't it? So look at there. So AC vector dot BD vector. AC vector means what is the meaning? First one by one we have to find out, isn't it? First, so AC vector is equal to AB vector plus BC vector. AB vector plus BC vector. Then we need BD vector, isn't it? So BD vector is equal to BC vector plus CD vector. BC vector plus CD vector. Look at there. This is going to A to B direction, but this is going to C to B, opposite direction. So already, but AB is equal to CD. Look at there, AB is equal to CD, but reverse direction means we have to consider for minus sign. So AB vector is equal to negative CD. Therefore, instead of CD, we can write it negative AB, isn't it? So therefore, BD vector is equal to BC vector negative AB vector. Now, condition AC vector dot BD vector. Because AC we have to prove perpendicular to BD. Therefore, AC vector dot BD vector is equal to, what is the meaning of AC vector? AB vector plus BC vector. So we can write it AB vector plus BC vector, then dot BC vector minus AB vector. Just interchange because both first term both term positive. Therefore, BC vector plus AB vector dot BC vector minus AB vector. Look at there. A plus B into A minus B. Therefore, we can write it A square minus B square form. So, A square minus B square form means BC vector square minus AB vector square. Therefore, BC vector square minus AB vector means square means we can write it without. So, BC square minus AB square is equal to BC square means what is the meaning? The BC condition, each and every length will be equal. Now, therefore, we can write it a square minus a square. So, plus a square minus a square cancel means answer we have 0. Therefore, we can write it AC vector dot BD vector is equal to 0 means we can say AC vector perpendicular to BD vector. Therefore, we can write it hence proved. Okay, I will continue the next question. Question number 5. Using vector method, prove that if the diagonals of a parallelogram are equal, then it is a rectangle. First, you have to understand what is the difference between parallelogram and rectangle. Okay, I will draw. This is one parallelogram. Now, this is rectangle. This is parallelogram, okay. Let's say A, B, C, D. A, B, C, D. First, what is the similarity? What is the same step will come both sides? Definitely we can say the AB length is equal to CD, as well as here also AB length is equal to CD. That is a similarity step, okay, each and every time. Parallelogram also length CD is equal, as well as rectangle also CD is equal. But a difference we can say, so many different steps is there. Example, here look at there, each and everything 90 degree, no? 90 degree, then only we can say AC is equal to BD. But here it's not like that. Definitely we can say AC is greater than length comparing the BD. The AC length is greater than BD. There is a difference. Then another one important things, here is greater than 90 degree means this is actually less than 90 degree. As well as opposite side also, one part greater than 90 degree means another one part less than 90 degree. But here it's not like that. Rectangle means all this side we have the 90 degree. That's why we can say AC is equal to BD. But parallelogram it's not like that. But given condition, one person coming to me, they are saying rectangle diagram is showing, but the person saying, sir, this is one of the parallelogram, each side will be equal. But I am saying it's not a parallelogram. Why? I will explain, okay. So look at there, AB, so parallelogram condition means first we have to show AC vector is equal to, AC vector means how to find out AB vector plus BC vector. AB vector plus BC vector. Then BC, AB is clear, AC is clear. Now BD vector means BD vector is equal to BC vector plus CD vector, isn't it? BC vector plus CD vector. Already we know AB vector is equal to negative CD. Why? Look at there, A to B going to forward direction, but C to D reverse direction. That's why consider for negative. So AB is equal to CD, but negative CD. Okay. Instead of CD, we can write it BC vector negative AB vector. The given parallelogram are equal. Or equal means we can say AB is equal to CD, isn't it? The given AB is equal to CD means both sides square means, then only if we take square means we can write it vector form, isn't it? Both sides square means AB vector square is equal to CD vector square. What is the meaning of AB vector? Sorry, is equal means, sorry, diagonal, no, AC is equal to BD. Sorry, my dear. So given is equal condition, actually AC is equal to BD. AC is equal to BD means squaring on both sides means AC vector square is equal to BD vector square. AC vector means we have the answer AB vector plus BC vector. So AB vector plus BC vector the whole square is equal to BD vector square means BC vector minus AB vector. Now left hand side a plus b the whole square form, a square plus 2ab plus b square. We can write it ab vector square plus bc vector square plus 2ab vector dot bc vector is equal to opposite side a minus b, a square minus 2ab plus b square. So we can write it bc vector square plus ab vector square minus 2ab vector dot bc vector. So there ab vector square, bc vector square, bc vector square, remaining 2ab vector dot bc vector. Negative term bring out opposite side means plus 2ab vector dot bc vector is equal to 0. Therefore 4ab vector dot bc vector is equal to 0. I mean 4 bring out opposite side means 0 divided by 4. So 0 divided by anything means answer we have 0. Therefore we can write it ab vector dot bc vector is equal to 0 means we can write it ab vector is perpendicular, isn't it? But perpendicular condition means look at there. So ab vector dot bc vector means ab and BC. This is 90 degree now because the common term B is there. Therefore, we can say angle B is equal to 90 degrees. So, angle B is equal to 90 degree means definitely we can say whether ABCD parallelogram or right angle. Already I told you what is the difference between parallelogram and right angle. So, in parallelogram actually greater than 90 degree or less than 90 degree. But here we have the proper the step also if we have the 90 degree solution. So 90 degree means definitely we can sure ABCD is a rectangle. ABCD is a rectangle. Okay, hence proved. Okay, I will continue the next question. Question number 6. Prove by vector method that the area of quadrilateral, okay, ABCD having diagonals AC and BD, we have to prove half into modulus of AC vector cross BD vector. So quadrilateral condition A, B, C and D. So diagonal spot, look at there. So quadrilaters means 4 sides are different length. Okay, now so AC and BD condition proof let ABCD be a quadrilateral, be a quadrilateral. Then next step, AC and BD are true diagonals. AC and BD are true diagonals. Okay, so true diagonals. Now the condition vector area of quadrilateral ABCD is equal to vector area of triangle ABC, isn't it, plus vector area of triangle ACD. The first condition area of triangle means half into ABC means AC AB vector cross AC vector, then plus again area of triangle ACD means AC vector cross AD vector. Now look at there, starting the proof actually starting with the AC, no, just we have to interchange means since cross product means negative sign, isn't it? Again half into negative of AC vector cross AB vector plus half into AC vector cross AD vector. Now each and every term, first term also half into AC vector common, second term also half into AC vector common. Take common outside means inside their negative sign. So half into AC cross product, okay. Again negative AB vector, then there is positive sign AD vector. Now again half into AC vector cross, look at there. Negative AB means if you change convert for positive means BA vector, isn't it? So BA vector plus AD vector. Again half into AC vector cross. BA vector plus AD means BD vector, no diagonals. So we can write it BD vector. This is what is the value? Vector area of quadrilateral. So without vector line we can write it means area of quadrilateral ABCD is equal to area of quadrilateral ABCD is equal to modulus sign will come, isn't it? So half into modulus of AC vector cross BD vector. Hence proof. Look at there. AC vector cross BD vector. Hence proof. Okay. So I will continue the next question. Question number 7. Prove by vector method that the parallelogram on the same base and between the same parallels. Example, one more parallel will come inside the parallel. Okay, this is one of the parallel means. Then another one parallel also will be meet. Okay. So this is A, B, C and D means this is considered for C dash and D dash. Okay. Then now proof of the point. Let ABCD and ABC dash and D dash be the parallelogram between the parallel with the same base. Okay, one of the condition. Now so area of parallelogram ABCD is equal to area of parallelogram ABCD is equal to area of parallelogram AB, C dash and D dash condition. Okay, I am moving to the first condition. Area of parallelogram ABCD is equal to area of parallelogram ABCD is equal to AB vector cross AD, isn't it? Now so AB vector. Now the AD, look at there. What is the meaning of AD? So AD dash plus D dash D, isn't it? So AB vector cross AD dash plus D dash D vector, isn't it? Now again AB vector, each and everything into cross means AB vector cross A D dash vector plus again AB vector cross D dash D vector. Now the second condition, look at there, AB vector. So AB vector, then D dash D, D dash D. This is parallel, no? This is one of the line, this is parallel. But in a dot product already we know so many problems we are discussed. When A vector dot B vector is equal to 0 means what is the meaning? A vector is perpendicular to B vector. But in cross product, when A vector cross B vector is equal to 0 means A vector parallel to B vector, one of the important property, okay? Some differences there, you have to understand, okay? A vector cross B vector is equal to 0 means A vector parallel to B vector. Therefore, we can write now AB, this is actually AB vector is parallel to D dash D. Therefore, we can write it. This is whole term considered for 0 now. Therefore, AB vector cross A D dash vector plus 0 means the condition AB vector cross A D dash vector. Look at there, AB vector, then A D dash. A D dash means opposite direction, A, B, C dash and D dash. This is whole term will be equal to area of parallelogram. This is will be equal to area of parallelogram AB, C dash and D dash. Hence proved. Okay. I will continue the next question in next class. Okay. So I hope you are satisfied in this session. If you have any doubt, please put in comment box. I am ready to clarify your doubts. Okay. I will continue the next session. Bye bye.